we're trying to look at how to change a decimal number with point to binary. So for instance, let's say I have a question like this. I have 10.35 for instance as a question. So this number we have it in base 10. So and the intention is what? We are to convert this to base 2, like convert this number in base 10 to binary. So meaning we want to convert it to base 2. So what we just need to do has been explained yesterday. We will still follow the same procedure. So this one is just like a review of what we discussed to know whether it is properly taken or not. Now solution, we have 10.35 in base 10. So this one is a number in base 10, a decimal number with point. So now, and I make it clear that a decimal number has what? 2 parts. So the part before the word, the point, and what we have after the point. What we have before the point is the integral part, right? And what we have after the point, talking about point, whatever thing that follows. In this case, 0.35. So that is the word, the fractional part. So what we have here is equal to, we can split this to this, 10 in base 10 plus 0.35 in base 10. Don't be confused. This 10 that we have here, it is what seen as a single word number, not 10 per se. 1 is on its own, 0 is on its own. Because we know that number in what? In base 10 should range from 0, 1, then down to what? To 9. So this number is just what? 1 and 0. But we know that what? We are having it in base 10. So what we need to do is this one, we'll change it to base 2. This one will be changed to base 2. So I just want us to what? To observe something, that this value without point, this one without point, if you want to change it to base 2, we'll be dividing it repeatedly by 2 since we already have it in base 10. But this one that involve point, meaning point a number, because 0.35 can also be seen as 0.35. This one, if you want to convert it to base 2, we'll be multiplying it repeatedly by 2. And the number in the circle will give what was the answer. So now let's do it together. So for this 10 that I'm having here in base 10, it will be equal to this. So we want to divide by long division. So 10 is here. So we'll be dividing it repeatedly by what? By 2. Because the intention is to change from base 10, to change 10 in base 10 to base 2. If the question also asks me to change this 10 to base 3, that means in that case I will be dividing repeatedly by what? By 3. And I will be recording that the remainder. It's still the same procedures. So now here I will be dividing repeatedly by 2. 2 in 10, 5, remainder 0. 2 in 5, 2, remainder 1. 2 in 2, 1, remainder 0. And 2 in this is what? 0, remainder 1. You must always ensure that the last value here end with what? Is 0. Anytime we see that this value is beyond this, so we'll just write 0, meaning this one is more than this. We'll write 0 here. Remainder, whatever thing that is there will be the remainder. So back to the solving. So our answer will be taken from bottom to what? To top. So that means we have 10 base 10 to be equal to 10, 10 in base 2. So now it's now for us to convert this to base 2. we have 0.35 in base 10. So for this, we won't be dividing repeatedly by 2. We'll rather multiply repeatedly by what? By 2. So it will be 0.35 times 2. 2 times 5, that is 0. I'll write 0, carry 1, right?
Yes.
So this is the 1 here. 2 times 3 is what? Plus the 1, that is 7. 2 times 0 is 0. So the number that we have as our integral part, the one that we have as our integral part for this result, we are going to circle it, meaning the value is now what? 0. The new state of that value is now 0, irrespective that it's 0 that is there initially. So now, I'm going to circle this. So we'll move again, times 2. 2 times 0 is 0. 2 times 7 is 14. I'll write down 4, carry 1. This is the one I'm carrying. 2 times 0 is 0, plus the 1 carried. So that is 1. So that is 0.1. So we'll circle this one again, which is the integral part of the new result. So we go again and multiply. So this process, in some cases, it terminates, and in some cases, it does not terminate. But yeah, this one does not. But it depends. For some question, you will see that you end up having the result here to be 0.000. And in that case, when you keep multiplying by 2, it will be returning 0. So there is no point. That means that won't terminate. So here now, let's still solve one step. But for a question like this, there might be what? Additional information, leaving your answer to a specific what? Decimal places or significant figure. It depends on the question. So here now, 2 times 0 is what? Is 0, right? 2 times 4 is what? 8. And 2 times is 0. You know, the new value here is 0, so that is 0. So we circle that also. So I can continue. But with the look of things, it seems this one won't terminate. From the look of things, you keep solving for this. It does not terminate. So let me just stop here. That means 0.35 in base 10 is going to be equal to 0. It's going to be 0. What we have in the circle. So it's going to be this 0. What we have in the circled number, that is 0, 1, 0 in base 2. A question?
So what's the rule for us to say, okay, this has terminated?
This is what? Terminated.
Yes.
So terminated in the sense that here, all the value will be what? 0.00. So, you know, when you keep multiplying by 2, you will still be having 0. And the point is, if I should have a value like this, 101.11000, I can keep adding more zeros. Do you know that these zeros that is here, I can neglect it. I can just come and write 101.11. These zeros here, after point, like at the extreme part, talking about towards the end, can be neglected. So far it's not in between 1. It's not midway. We can neglect this. You can prove me wrong by what? Pressing your calculator. Just press this value. What your calculator will return as value is what? 101.11. Meaning these zeros, they are just there. But we can what? Ignore them. I can decide to what? To add more zero here. At the back of this. I can add more zero here. But those zero has no what? Importance. So I can just neglect them and simply write 101.11. But in a case like this, 101.101000. Now, the question is, which zero are we going to neglect here? Will this one be part of the what? The zeros will be neglecting. This one is not part. It's only what? This one that is not found midway between numbers. Why we are neglecting it is not because we are having a point here. You can't tell me that if I have 1 1 0 1 0 that this 0 will be what? Overlooked. That this 0 will be overlooked. No, because we didn't have a point in between. Am I making sense? I've answered your question.
Yes.
Thank you.
So this one now, it's 0 terminated.
This one is 0. This 0, right?
0.
Yes, we can just write 0.01. But one thing is why I might still decide to leave it. You know, I just stop somewhere. There's no instruction that leave your answer to 3 decimal places.
You can continue the other one.
Yes, you can continue, but one thing is this process does not end, does not terminate. See, it doesn't terminate.
You said something that this decimal, that some of them terminate.
Yes.
Which is that the ones that are not recurring decimal. You don't have like, it's not like pi, or it's not like the one that with that 1 divided by 3, that will have 0.3333333. That's the one that is recurring, right?
Yes.
And then we have another one that that can actually end, that has, like, if you calculate it, that's a specific.
Yes. So meaning the process does not continue.
Yeah, it does not continue. So my actual question was that whether I did the one like the one for like the one that I think we did 3/4 yesterday, I think it was 0.75. I was like, okay, this is the last one. At what point did I get that?
Yes, like what we are having here won't result to that. It won't terminate in the sense that, let's assume that I have this end number here. After multiplying this value by 2, for instance.
No, I get this one. Yeah, I'm saying for the other parts. I get this one that doesn't terminate, I will stop.
Okay.
So I'm saying if I'm doing for the one or 3/4, the one that can be like, if I went 0.05, how do I know that everything will be 1 1 1 1 or everything will be 0 0?
Okay, let me use this one as example. Let's say we have 3/4, right?
Yeah.
So this 3/4, the answer is 0.75. How come? So we are using this approach, long division, right? 4 will be placed outside, then 3 inside. Now, how many 4 can we see in 3? It's not possible, right? So we are going to put 0 here with point. So because of this point, we are going to add 1 0 at the back of that 3. So we have 30, right? How many 4 can we see in 30? That is 7, because 7 times 4 is 28. So 7 times 4 is 28. So that 28 will be subtract from 30. We have 2, right? So we go again. How many 4 can we see in 2? Is what? It's not possible, because this 4 is more than 2. So because of this point that we've added earlier, we'll add 1 0 at the back of that one, 2, to make it 20. So how many 4 can we see in 20? That is 5. 5 times 4, 20. So here, what we subtract? 0 minus 0 is 0. 2 minus 2 is what? 0 is nothing. So here we have remainder of 0. So anytime we have remainder of 0, the assumption is what? It terminates. Because there is nothing to solve again at this point. But looking at what we are having here, this process still continue, because we still keep what? Multiplying for this.
That means the example that you have right before. Because let's give this 10.35 now. Yes.
So
the one that we are doing the multiply for.
Yes.
For the decimal. Are you saying that we don't have any decimal point that will actually terminate?
No, there are some that will terminate.
That's using this press of times 2.
Yes, there are some that will terminate for this.
So my question is, how, like, you are not getting my question yet. How do multiply now? 0.7.
Oh, I'm going to write the question down that will lead us to that.
So something with 75 will terminate.
Yes, something with 75, 0.5, 0.25, yes.
So my own question is, at what point, look at this one now. Exactly. At what point, what answer do we get on the bottom that this has terminated?
So you're saying that it's identify if it's something will occurring or if it has actually terminated.
Yes, that's my question.
It's just all of this is just your intuition. this one not permit, this one permit.
No, you must add certain rules.
No, you for now just say this one permit, this one permit.
Okay, now back to what we are solving. So 10.35 in base 10 now is equal to, you know, we splitted it to this, right, plus this, right, and this one we have a value to this, right. So the value of this one in base 2 is what? We have it to be 1010 in base 2, right, plus this other value, this one in base 2 is this value. So it's going to be 0.010 in base 2, right? So here now, when we add this plus this, so definitely this one, we only add to the integral part of this one. So the answer is going to be 1010 base 2 plus, oh sorry, point 0.010 in base 2. So this is what we are going to have to be our answer for this question. So I'm going to give you something to what? To work on, because I want to join the meeting. So you will be solving this. So a practice question. Practice questions. So you convert to binary the following. So the A part is 23.25 base 10. B 1, 2, 3. 1, 2, 3. Point 0. 75 base 10.
075.
Yes. No, there is no 0. 123.75 base 10. The conversion of a base 2 number to base 8. There's a direct way of doing it. Like, let's say the question we have now is convert. Can you help me with the answer that we have for that base 2? The answer for the base 2 that we have.
1010.
How many one?
10.
1 0 1 0 1 1 0.
Yes. 111. It's not this class, you write down. Which class? Yeah, another class. Senior class.
We have 1 0 1 0 1 1 0.
Oh, sorry. I thought you had senior class.
So this is what we have. So this one is correct. In base 2 to octa. Octa, that means in base 8. So now we want to move from 2, we want to move to 8. And 8 is the same thing as 2 to the power of 3, right? This one is the same thing as 2 to the power of 1. So probably there is a way we can play around this, a faster route. Or probably we can use the long route, meaning we converting this base 2 to base 10, then from base 10 back to what? To base 8. We will try both approach. Do you agree? No. So let us try the long cut first, right? Should we?
No.
We should not. Okay, now. No. Solution. So the shortcut would be, so we know that 2 to 8 is what we want to achieve. But 2 is still equal to 2 to the power of 1. And 8 is equal to 2 to the power of 3. So this 3 here, we'll use it to rearrange this into what? 3, into 3 bits, starting from the right hand side. So we have 1 0 1 0 1 1 0. So starting from the what? The right hand side, I will have 0 1 1, that is one group. So we have what? 0 1 0, that is another group. Then we have 1. But you can complement it with what? 0 0.
Okay, you are shifting 3 times.
Look at something. You know, we have 2 to 8, right? 2 to 8, right? And this 2 is still equal to 2 to the power of 1, right? So 8 is equal to 2 to the power of 3. You will notice that both of them, they are in the same base, right? So this what? Power of these 2 for the 8 tell us the grouping. So we have to group it in how many, like the bits that we are going to have is going to be 8 bits. Oh, sorry, 3 bits, sorry, 3 bits. So you are going to make that arrangement from the right hand side towards the what? The left hand side. So this is what we have here. So if you want to complement this, the complementary of this one will just be 0 0. Do you get it now? Yes. Now, each of these value here, this one is in base 10, this one is in base 10, this one is in base 10, likewise this one is in base 10. So each of those what? I say base 10, base 2, pardon me. So we are going to what? To change each of these base 2 number to base 10. So pardon me for that word mistake. So now let's convert this one to what? To base 10. You know, if you want to use the power approach, like the weight approach, sorry, this one will be 1, this one will be what? 2, then 4. This one will be what? 1, 2, then 4. This one will be what? 1, 2, then 4. So now 4 times 0, you know, we'll just discard what? Those one with 0, right? So 1 times 1 is 1. So everything here, when converted to base 10, what will it result to? Result to 1. And everything here, what will it result to? Result to 2. Everything here, what does it result to? 4 times 1, 4. 2 times 1, 2. This 0 will discard it. That is what? 6. So in base 8. Just 2 lines.
You are not showing your workings. How can I convert in just 2 lines and get the answer? Who did you call?
Okay. So I can prove myself by using the other what? Approach.
No.
But yes, now the other approach, this is what you need to do. First, convert to a common base. So the common base here is going to be 10. So you then move from that base 10, you now convert that base 10 to base 8. So you see that it's this same value we are going to have. Please, I believe that one is what? Is settled right.
Yes, sir.
So we can also add numbers in base 8. We can subtract number in what? In base 8. It's still the same approach with what we've known before. So though before we look at that, let us look at hexadecimal. Or let us solve question on that before moving to base 16. Hexadecimal. Now, let's assume we have this question. Let's say we have this question.
The practice question.
Not yet. No, I will send question that you will play with, but just try to attend. It's not mandatory. Do you understand? So I'll just draft it out, like send it, because you need time to do some other things.
Like how many?
It might not be that much because I know time is very important here. So just for you to brainstorm, and that is all. So
this is not where I'm going. That's not going. Wait for it.
So now let us just look at addition. Let's say we have 1 5 4 base 8 plus 243 base 8. If I may ask, if I have this 297 base 8 and 281 base 8, and I have 271 base 8, which of these is valid and which one is invalid? This is wrong, this is wrong, then this is valid. Thank you. Thank you. Now, you know why. So, we want to solve this. So, these two numbers given to us, are they valid? They are valid number, right? So, is equal to the number where we have 154, we have 342 here. So, we want to add. Remember, in base 8, we can't have 8 as a number in base 8 or number beyond what? 8. Or number less than what? 0. All those numbers, they are excluded in this system. So 4 plus 3 is what?
7.
We can have 7, right? So I will write 7. 5 plus 4 is what?
9.
9. But can I have 9 in base 8?
No.
So what did I need to do? That 9 will divide it by what? The base number. So what will it give? 1 remainder. So I will write what? The remainder. Then transfer that one to the next number. So we have what? 4. That is 417.
Okay.
So modular arithmetic has an application. It's an application form of number base. And that is our next topic.
Modular
Arithmetic. And it's something you've been seeing all this while. Like when an operation keep what? Moving around a circle. Like when a digit what? Keep what? Revolving around. So that concept is what? Modular what? Arithmetic. Like our work clock now, the way it works, the principle is behind what? Modular what? Arithmetic. We'll see that. And while talking about these substitution method, can see what? Cipher what? Substitution method. We'll what? Explain that also. It also depends on modular arithmetic. Modular arithmetic really have functionality, more application in cryptography. So our answer here is what? 417 in base 8. So that is the answer to this question. So let us look at subtraction. Just one question, then we'll move on. Just one question, then we'll move on. So let's say we have this. Let's say we have 2007 base 8. That is 2007 base 8 minus 1776 base 8. Like, we want to simplify 2007 base 8 minus 1778 in base 8. So now, it will be equal to, you might be saying that I'm using equal digits. Know that sometimes you might have what? Non-equal what digits. So the idea is you know how to play around it.
Yes.
So it won't be that, but I only solve 2-digit values. I didn't extend it to what? More digits. So no excuse. Now this one will be, we have 2007 minus 6 will be here, 771. So let's play around this together. Let's play around this together. And for some question, they will give us a subtraction operation like this. They will ask us to find the missing value. They will give us one value, the other one will be star or true. They will give you the answer. They will ask you to find the missing what answer. So watch out for that. It's still simple. It's still same thing that we are what explaining here. Like for instance, let's say I have something like this now, 2007 star 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 star. I have minus, and the answer is given. Let's just assume it's an assumption. Let's say the answer is what, 406, for instance. So it's not for you to find this. But how are you going to play around this? It's very simple. For you to know this missing word value, it will be that subtract this answer from this other one. We give you what? This missing one. Like you subtract this one, this answer from this one, we give you this one. It's just like, let's change it to equation normal. This one that is missing, everything that is missing here, let's assume it is what? X. Everything that is here, everything that is here, let's assume that it is what? X. Let's now change it to equation. It will be this value 2007 in base 8 minus x is equal to 406. This is a simple equation. So you collect like terms. This one will move from here to here. This one will come and meet this one. If we go 2007, positive will change to negative, 406 equal what? X. So x is equal to the difference between these two. So that is how you solve that. So this one is just what? A kind of hint, should in case you come across something of such. But I might give you something of such. Now let's do it together. 7 minus 6. Remember, what we are doing is in base 8. 7 minus 6.
1.
It is 1. We can have 1 in base 8. Is 0 minus 7?
No.
Not possible. Now we'll move to the next number, the neighborhood. Can we borrow from this man?
No.
This one, it is what? It is a useless man. Because it's empty. Now he can't rescue what? Us here now. Then we move to the what? To the next person, right? That is 2. So this one we can borrow from this. So when we borrow from this to this one will be what? 8. Wow. Sabi buku. From here to here, 8. This one now reduce to 7. So have that in mind. 8 minus 7 now. 1. 7 minus 7.
0.
What is left here?
1.
So 1 minus 1.
0.
So you know those zeros, they are useless, right? So now, 0, 0, 1, 1 is same thing as what? 1, 1 in base what? In base 8.